Well, now that we talked a little bit about technical drawing or drafting and the tools and equipment that we use and some of the techniques that we use, next we're going to talk about the ways that we draw and the ways that we actually put drawings on a page. And so typically when we do drafting, whether it's by hand or in a CAD system, we're going to use a multi-view drawing process. And in a multi-view drawing process, we have more than one view on a particular drawing page. This provides another view or a combination of views of a particular object. And so as you can see here in kind of the drawing that you see here, we have multiple views of this particular drawing right there. And the advantages of this is that we can show true shape and size of our particular drawing. So of the different angles of that particular object, we can show true shape and size. And that's an important component to remember there. Technical drawings do show true shape and size of the objects they're representing, as compared to, let's say, a sketch is not necessarily going to show the true shape and size. Now that doesn't mean that we don't scale drawings. So this part that you might see right here may be 8 feet long. But we're going to use a scale to scale it down, but it still shows the true shape and size based on whatever scale that we're using for that technical drawing. And therefore everything will be in proportion to each other. One of the disadvantages, however, is sometimes it's hard to visualize. We will not always have this pictorial style fourth view up here in the top right corner. We may only have the other three views that you see there. And so sometimes it's hard when you just have those 3 views to really get an idea to visualize of what this particular product looks like. So in the process of doing a multi-view drawing, we can use what's called orthographic projection. And orthographic projection is the method used to produce the multi-view drawings. And therefore we use projection planes to project the different sides or views of this particular object. The standard 3 views or planes that we use is the front, right, and top view. So in this case, this is the front view here, which correlates with what you see right here in the front view. We have a right side view here, which correlates with the right side of the object. And then we have the top view here, which would be a view coming directly down on top. So basically when we do orthographic projection, we take our object, whatever it might be, and we start with having a front view in the front. Then we take and we would rotate that object to demonstrate a side view over here. And then again we bring it back to original, and to do a top view we're going to rotate it up yet again. So we would just take and rotate that object on different planes to represent those sides. And so each one of the sides are going to correlate together. For example, the height of this front view is going to be the same of the height of this view over here. The width of this view right here on the right side, which is this same width, is going to be the same as this width up here at the top, because it's all the same. So everything is connected together, and the combination of these 3 standard views, or the 3 principal views, gives us all 3 dimensions of that particular object. Each view only shows 2 dimensions. So for example, this shows the length and the height. This over here shows the width and the height. And so with each one of these, the top view shows the length and the width. So the combination of those 3 gives us all 3 of the 3 principal views, but each one, and that's important to remember, each one only shows 2 dimensions depending on which view you're looking at. As we talked about in the previous chapter, when we do multi-view drawings, we're going to use the alphabet lines, and those are important because they help us to understand the different views. If I go back here and look at this drawing, you can see here that this front view would correlate with this front that you see right here. However, there are other things going on in the background that we don't see or that are behind this front plane, but we still need to identify those. So in that case we would identify those as hidden lines. So anything that's covered up by something else we would show as a hidden line. So for example, even this circle that you see right here, because part of that circle is on top or above that angle line, that would be a solid line, but where it's covered up, it's going to be a hidden line right there. So we use these different types of lines to help clarify what's going on in that drawing. And then we do have a line precedence, meaning that visible lines would overtake a hidden line and so forth. Another type of multi-view drawing that we can use is called a section drawing. And the purpose of a section drawing is to show the internal features. And so in this case we would use what's called a cutting plane line or a cutting plane to essentially cut this part whether it be a quarter out of it or a half of it taken away. But you can see here that where we have all these threads going on the inside of this part, if we were to simply try to draw that as a normal multi-view drawing, all of these lines would have to be hidden lines. And that can be very confusing. So the purpose of the section drawing is where we can take a chunk out of that particular product, and then that way all those internal features we can show as regular object lines, which makes it a nice clean and crisp drawing that we can really understand what's going on. So section views are very important in our technical drawings. Another view that we might use is what's called an auxiliary view. And so as you look here at this part where it has this angled feature on it, here's a front view, a right side view, and a top view. Well, if you remember, our multi-view drawings are supposed to show true shape and size. Well, because of the angle of this part coming up here, as we rotate this to the right side, as you can see here with the circular part, that's actually shown as an ellipse. Because again, the angle and the way that it shows, it just presents it as a circle that's been squashed, if you will, what we call an ellipse. But that is not the true shape and size of it. So in order to get that true shape and size, we have to use an auxiliary view, where you can see we have an auxiliary plane line here, and then we rotate that object based off of this angled line, and this will then give us the true shape and size of that particular part. So auxiliary views help to show the accurate true shape and size that may be distorted because of the angle of a particular part. We can also use assembly drawings. These are certainly very popular as you get your manual, your instructional manual with a product. Very likely there's an assembly drawing which simply shows how all of the parts of the object fit together. And so this is an important part for understanding a drawing or understanding a product, and if you're having to work on the product, this is important to know how to take something apart and how to get it back together. So those are some of the standard multi-view drawings that we use in our technical drawings. All of those have different purposes and places, but are important components to understanding the design and construction of a particular part or object.